can see that it says function ends, the processing time of function is 0.000061. Okay, so that was the processing time of the function. So I hope you have got the point. Okay, so the next topic is system limits. Okay, so SUSV3, which stands for Single Unix Specification Version 3, it adds a lot of new functions into C and C++ library. So SUSV3 specifies limits that an implementation may enforce and system options that an implementation may support. So often it is desirable not to hard code assumptions about system limits and options into a program, since these may vary across implementations and also on single implementation, either at runtime or across file systems. Therefore, SUSV3 specifies methods by which an implementation can advertise the limits and options it supports. For most limits, SUSV3 specifies a minimum value that all implementations must support. Additionally, each implementation can advertise its implementation specific limits and options at compile time. Okay, so it has a constant definition in limits.h header file, or specific limits and options at compile time. So the example that we're gonna do is related to limits.h. So I'm gonna show you that what limits.h contains. Okay, so what are those limits that it put on some of the data types as well, and how it affects the system. Okay, so obviously the examples in book are different. Okay, so not by any means these examples are related. So I'm going to show you a very specific and a very easy example. So this is basically a table in which you can see that character bit, it has a value of 8 and it defines the number of bits in a byte. Okay, so similarly we have all the other macros and they have their own limits. Okay, so now let's go ahead and let's try to do some practical examples. So the limits.h header, it determines various properties of the various variable types. The macros defined in this header limits the values of various variable types like character, int, and long. So we will open this C program.c. We don't need this function, but we do need the integer main body type, because whatever we're gonna write inside of this main function. So we'll remove this, and instead of time.h we are going to write here limit.h. okay, so this is the header that we have to have. It's limits.h. and the other thing that we're going to do is that we're just going to simply print out the range of the macros that we have, right? So we're just going to write here printf. Let me just write here printf, and I'm just going to show you the limits, the general limits. So let's just start from the from down here. So just start from here, long max and long minimum. Okay, and then we'd see int max, int minimum, short max and short minimum, and then character max and character minimum, and then s character max and s character minimum. Okay, so s means signed basically. All right, so now let's go ahead and let's try to write some code. So we write here long max or long minimum, and then we put here percentage ld for long. Okay, and we write here long minimum. Okay, then we put a semicolon, and now we're just going to copy paste it and we're going to edit it. Okay, so we just do that. We write here long max, and we percentage ld would remain the same, and instead of min we put here max. Okay, and then the other thing that we're gonna have is gonna be character minimum. Okay, so for character minimum, we're gonna have %d sign. So we just write here character minimum, and we remove this L, and we write here char minimum, and we just copy this and we come here, paste it, and we type in here character max. Okay, and then we come here, and then we're gonna try the short minimum. You can try all of them one by one, so I'll just write here the character bit, and we are all done. Okay, so you can try the other ones on your own. Okay, so you can say that where these values are coming from. So these values would come from this limits.h. Okay, so we'd write here %d, and then we'd write here character bit. Okay, so after that, there's another thing that we would like to do is that /n, which would basically do nothing, but it would move the cursor to the next line, so that the output is not in an awkward position on the same line. So we just want to separate it on each line. So for that we put /n, and now we are all done. Okay, so we'll just save it, and here we'll write here gcc c program and then -o tst, and you can see that it hasn't given us any error. So now we'd basically run our binary file, we hit enter, and you can see that we have got the values of the all the long min, long max, character minimum, character max, and the character bit. And if we match that in the table, let's go to the table. And if we match that in the table, and if we see that character bit has 8 value, yes, and character max has 127, and character minimum has -128, and the long max start from 9222337, and then they have converted that into hex value, and you can see that it has -92. Okay, so I hope you have got the point. So now we'll move on to the next topic. Okay, so the next topic is related to the system and process information. So I'd show you first that how to obtain information about a process. So for each process on the system, the kernel provides a corresponding directory named /proc/pid. Let me just write it down here for you. proc/pid, which we are going to use shortly. So PID is the ID of the process. Within this directory are variable and the various files and subdirectories containing information about that process. For example, we can obtain information about the init process, which always has the process ID 1. And by looking at those files under the directory proc1, among the files in each /process/pid directory is one named status, which provides a range of information about the process. Okay, so first of all, let's go on and let's practically figure it out that what I'm talking about. Okay, so what we're gonna do here, we're gonna write here cat/process as we have talked about, and then we're gonna write here the process ID or the PID, and let's say that we write here 1, which is for init process, and then we write here status as we have talked about. So now if we hit enter, you can see that here we have a lot of information. So the first information that we have is name, which is systemd, name of the command run by this process. Okay, so state, which is S. Here on my system, it's instead of init, the name of the first process is systemd, and the idea is that the first line that you see, which is name, is the name of the command run by this process. Then we have state, which is the state of this process. Then we have TGID, which is thread group ID or traditional PID. You can also get it by using get PID. Then we have PID, which is the actual thread ID. Then you have PPID, which is parent process ID. And then you have the tracer PID, which is PID of tracing process. And you can go on, and I could actually name everything that we see inside of it. And then in the end we have voluntary context switches, and then we have involuntary context switches as well. Then we have stack usage high watermark as well. Okay, then we have memory nodes allowed, which is like 0. Okay, so basically that was the detail. So make sure that you do it on your own and you go through all the details. So now let's come to the system. For system identification, we have a method called as uname, or functions and methods are same, so that is called as like this, uname. So the uname system call returns a range of identifying information about the host system on which an application is running. Okay, so if it returns 0, that means success. If it returns -1, that means error. And let's see how we use it actually in our example. So what we are gonna do is that we're gonna come to here. So this example, some part of this example is in the book as well. So now what we're gonna do is that we're gonna write here stdio.h, stdlib.h. That's what we need, stdlib.h. And the third library, we actually need 4 libraries in total. So the third library that we need, that is errno.h, which is error. So, and then we need the UTS name header file, which we would have directly from the system, from within the system. So we'd write here include, then we have /sys, which stands for system, and then we have here UTS name .h. Okay, and after that we go to inside the main function, and inside the main function we write here struct UTS name buffer, and then we initialize this ERRNO as 0. Okay, and then we have the if condition, and inside this if condition we write here uname, and then we are gonna write here and basically we are gonna pass the argument, and the argument is gonna be buff. So basically uname is the method, is the function, and inside that buff is the argument that we are passing. And now we're gonna check if that is not equal to 0. So for example, if it is not equal to 0, that means it certainly is what, -1. Okay, and if it is -1, then obviously that is an error. We want our program to not execute further and come out of it, right? So we write here uname doesn't return 0, so there is an error. Okay, you can write it here, and then basically you put a semicolon here. So now here what we would write, that would be considered outside of the if statement. Okay, so we'd write here exit, and then we'd write here inside of that exit failure. Okay, and then we put a semicolon here, and then we come out of here. In fact, let us put the curly braces here. Okay, so that it considers that exit inside the if statement as well. Okay, otherwise it should not exit